Welcome to The Explainer. Today, we're diving into how a new kind of automated detective is finding security flaws that have been hiding for years, right inside your web browser. And to get started, we're going to look at just how high the stakes really are. So just imagine this for a second. What if a flaw, a really critical one, was hiding out in your browser? Not for a month, not for a year, but for 8 entire years before anyone even noticed. Now, this isn't some made-up scenario. It's a true story, and it shines a huge spotlight on a massive challenge at the very heart of the internet. And that really gets us into the hidden dangers lurking inside your browser. I mean, every single time you open a new tab, you are stepping into one of the most complex pieces of software that exists today. And all that complexity, well, it turns out it's the perfect hiding place for some serious vulnerabilities.
Remember that 8-year-old flaw I mentioned? It was buried in a feature called HTTP-only cookies. Now, this thing was designed to be a shield, right, to stop malicious scripts from grabbing your login info. But for almost a decade, a simple little oversight meant that shield was basically useless. It was a security cold case, hiding in plain sight.
And this really gets to the core of the problem. It's this constant battle between complexity and security. We all want our browsers to do amazing new things, but every single new feature, every little update, well, it adds another layer. It creates more moving parts, more weird edge cases, and just exponentially more places for security flaws to hide.
So, you might be asking, why can't we just find these things? And that's a great question. It leads us right into why the old way of doing things, relying on human experts to check everything by hand, is just not cutting it anymore.
The researchers who dug into this whole problem argue that this isn't about one person making one mistake. Nope, it's a systemic issue. It's caused by a bunch of different factors all piling up at once, making it pretty much impossible for human reviewers to catch everything.
You see, our human security experts are fighting an uphill battle for a few key reasons. First, the actual rule books for how a browser should work, they're written in plain English, which means they can be vague and interpreted in different ways. Second, there isn't some master list of unbreakable security laws to check against. And maybe the biggest one? New features usually get tested all by themselves, but the real danger? That often pops up when they interact in totally unexpected ways with old, crusty legacy features.
Okay, so this is where the story takes a really cool turn. If our human detectives are totally overwhelmed, maybe it's time to bring in a machine. So let's introduce the hero of our story, WebSpec.
Now, to build this new kind of digital detective, the researchers grabbed 2 incredibly powerful tools. On the left, you've got the cock-proof assistant. You can think of this thing as a master architect, capable of creating a perfect, uncheatable blueprint of the browser. And on the right, that's the Z3 theorem prover. It's like a relentless logic detective that can test that blueprint against millions of scenarios in the blink of an eye.
So what is WebSpec exactly? Well, to put it simply, it's the very first framework of its kind. It uses this super rigorous machine-checked analysis to automatically hunt down logical flaws in the design of browser security. You know, the exact kinds of problems that we humans consistently miss.
The whole process? It works kind of like a flight simulator, but for browser security. First, WebSpec uses its architect tool to build that perfect digital model of a browser. Then, it defines those unbreakable laws we were talking about, the things that absolutely must be true for the browser to be secure. Next, it translates all of that into a language that Z3, our logic detective, can understand. And then, it just unleashes it. Z3 relentlessly searches for any possible way to break the rules. And get this, if it finds one, it doesn't just ring a bell. It gives you a step-by-step recipe for how to pull off the attack.
Okay, so this all sounds great in theory, but how does this machine detective actually crack a case? Let's walk through a real, previously unknown vulnerability that WebSpec sniffed out all on its own.
All right, first, let's set the stage. We need to understand this special security feature called _host_cookies. These are designed for really high security stuff. And the key rule, the unbreakable law, is that they cannot have a domain attribute. This is meant to lock the cookie to the exact website that created it, like login.website.com, and prevent a less secure part of the site, like ads.website.com, from messing with it.
So our little attack scenario begins. A user goes to a secure page, login.website.com. So far, so good. Everything looks totally normal. This is our trusted page. But then, that trusted page loads some other content in an iframe, and that iframe is coming from another part of the site, ads.website.com. It's still on the same main domain, but it's a separate and potentially less trusted place.
And now, here comes the crucial move. Both the main login page and the ad iframe use this old legacy trick to basically lower their security shields. By setting their document.domain to the parent, website.com, they're essentially telling the browser, hey, don't worry about us, we are friends, let us share stuff.
And boom, that's the opening. The script running inside that less trusted ads iframe can now reach outside of its little box and write a cookie directly into the cookie jar of the main login page. And look what it's writing. A high security _host- cookie. This shouldn't be possible.
And there you have it. The unbreakable law has just been shattered. The less trusted ad subdomain has successfully planted a high-security cookie on the trusted login page, completely sidestepping the protection that was supposed to be there. WebSpec didn't just find a bug in some code, it found a flaw in the very logic of the web.
Now, finding one new attack is pretty darn impressive, but the real impact here is so much bigger. So let's talk about what this all means for actually building a safer web for all of us.
In its very first run, WebSpec didn't just find that one new flaw. It systematically went through and found a total of 10 vulnerabilities. Some of them were brand new, like the one we just saw, and others were known bugs that it independently rediscovered. This is the machine seeing what we've been missing all along.
What we're really talking about here is a fundamental shift in how we do things, a real paradigm shift. We're moving away from relying only on overwhelmed human experts who have to imagine every possible attack, and we're moving towards an automated, mathematically proven analysis that can explore every possibility.
And honestly, this is the real game changer. With tools like WebSpec, we can now test the blueprint for new web features. We can find and fix these deep, logical design flaws before a single line of code even gets written, and long before they ever have a chance to make it into the browser running on your machine.
And that leaves us with one last, pretty fascinating thought. If machines can now systematically find security flaws that even the smartest human experts miss, what does that really mean for the future of the internet? What does it mean for that endless cat-and-mouse game between the people who build things and the people who try to break them? That's the question this kind of technology really forces us to ask. Thanks for watching The Explainer.